So we're back in an irregular galaxy, and I've found a hot oceanum. And the thing about the position of this planet, well, of course it has water, but the temperature is very high. You can see a lot of stars in the background. Now what separates them from the rest of the cloud, you see here, which is stars that are far away. The thing about this zone is that, let's zoom out. This whole zone is clustered with a group of stars. Now, I want to show you the center here. The thing is, it's the most bright part of the irregular galaxy. I mean, there's not a lot of these around. So I'll have to define it for you. But I mean, how do you know where these stars are actually moving? Where are they moving away from us? And where are they getting closer to us? Let's say we're on a planet in another star system, close to this one, but further away. Now, according to me, when you start to move and you're moving around the system, there should be some point at which these stars are moving away from us, right? Because I'm in a position where they should be approaching me or receding me. So why doesn't that happen? Why is this group of stars not moving? Now, I can slow down the speed just to check the relationship with one of the stars in front of another. Now, I could focus on any stars or any one star, and let's say we focus on these two here, those ones. That one there. Those two stars. Alright. So by gradual motion, with trying to see if they move to the left or right, we're not actually, we're being pulled in to them. Those two there, yeah. See what I mean? Like, try to overlay them. What happens is, let's see, we have to move, so we have to move to the sides, right? Alright, let's move out again. So why doesn't this happen when we move with a group of stars? And why is it so that, let's see, as we move away, let's say the further away you get, I mean, the more probability there is that all the stars will be transposed on all the other stars in the group to such a point where they're just a bright spot in the night sky. Now that's quite a question. In terms of moving around the star group and having it centered in the image before you, the cluster does actually appear. Let's see if we can juxtapose it in front of an open space, or we can juxtapose it so that it's in front of a cloud, like that. Now, what does that involve? That just involves placing them in a position. Now, these imagery technologies, they don't indicate the motion of the stars in some special way, other than perhaps to show that they do have some kind of precession, or which would take, I'm sure, millions of years, even in terms of a cloud like this, an irregular cluster having its own motion center, a type of kind of gauging system where the stuff in the center always remains centered, which would be an argument against black holes that seem to rotate in space at a faster rate than stars are observable, or which stars actually do, which in this case they do not. So in terms of a black hole perhaps being like a wormhole to these clusters that are centered within irregulars, it could be possible that we go into a black hole and we come out, we come out in a place like this, and we'd be wondering about the clouds around us. I mean, the galaxy center with a black hole has to go somewhere, right? Many suppose that it's like a wormhole and you displace to another part of the universe. Perhaps irregular galaxies could actually be the type of portals we were talking about on some of the previous videos on the irregular clouds, where you go into a part of space like that right there in front of us, and when you look back, supposing now we got clouds, when we look back we have cloud. Now the opening's shifted a bit down, so let's go through that one and then turn around. So let's go back. So again, in reference to the group of stars in the center, we came out there. There's actually a cloud in front of it. We move into the opening in space, and we turn back using the star cluster, and you can see, space opens up, then it is somewhere in the mid-range there between cloud and space. So its true position, if we could define the position of the space to be behind it, and then turn around so that, you see, we can't turn around until we see another part of space openings, and then that's already excluding our view, you see. It's getting dimmer. So is there some kind of position wherein the opening equates to a continuum as the opening? Let's try this way in. See that this is a dust, and we turn back on the cluster, and now it's in front of more clouds. Difficult, but there has to be one position to enter through